Okay, Ling 441. I just want to briefly walk you through the next homework assignment on Fourier analysis and a Formant analysis, or rather maybe a vocal tract length calculation, which is going to be due on Monday, November 16th, at the beginning of the official class time for this course. So the first part of this is required, and the second part of this is optional. It's something you can do only if you want to do it, and you can pick up 5 points total on the first part and a maximum of 5 possible extra credit points on the second part applied to your homework grade. So the link to this one is here, and I've already clicked on that. So you can find the relevant materials here. There's 3 links for this one. So to begin with, there's the homework assignment itself, which I've got up on PDF form, in preview here and also on my web browser. There's also, for the first part, an example of my neutral vowel, which I've played multiple times in both 341 and 441 classes. It sounds like this. It's also got relatively evenly spaced formants. The first one at about 500, and the second one at about 1500, and the third one about 2500, so on and so forth. So what you need to do is, first of all, produce or record yourself producing a vowel that sounds something like that. This is supposed to be schwa. But kind of most crucially, what you want to get in your recording are evenly spaced formants. So the second should be about 3 times the value of the first, and the third should be about 5 times the value of the first, so on and so forth. And on the basis of that, you should be able to calculate your vocal tract length based on the math that we've walked through in the lecture. Or at least I walked through it in the lectures that I posted, and hopefully you followed it well enough to be able to figure out how to use that math to calculate your own vocal tract length after measuring your formants. So yeah, what you need to do is record yourself producing a neutral vowel like schwa with evenly spaced formants. It can take some time to do that. I would recommend trying to produce something that sounds like this, sort of like but with your, like is wedge, right? So your tongue should be a little bit higher and a little bit further forward to get sort of this evenly spaced pattern. And so it may take a while to do that, but once you succeed, then record, keep that recording and send it to me. And then on the basis of that recording, make measurements of your first 3 formant frequencies. And then on the basis of those measurements, estimate your vocal tract length. So you may get slightly different values for if you base your vocal tract length measurements on the individual formants. You may get 3 different values. So what I would like you to do, and actually I'm going to add this to the homework, I forgot to do it before I posted it today. Thankfully, we've got plenty of time before the semester begins. But if you have slightly different values for your first, for your vocal tract length, for your first, second, and third formants, give me an average value for all 3 of those, which should hopefully be something reasonably in the middle and reasonably accurate for your particular vocal tract length. Also, when you do that, send me the work that you performed to calculate your estimate of the vocal tract length, i.e. send me the math. So that I can know what happened if you did something wrong and kind of give you credit for what you did right. And if you don't do that, I'm not going to give you credit for doing anything because then I don't know what you did, and that's half of the battle, really. Lastly, for this part, send me your height too if you want to. I know that's personal individual information, which you might not want to share, but if you do, it's kind of fun because then we can see what connection there is between your vocal tract length and your height. Usually there is a correlation, although it's not perfect. Okay, so that part is optional. The other part of this homework that is optional is the Fourier analysis, which is based on this other link I have up on the exercise page for the course website. So if you click on this, it says Excel spreadsheet with mystery waves for Fourier analysis. My voice is not really working today. Then it shows you this. So this is what the spreadsheet looks like. If you have trouble opening up the spreadsheet, let me know, but most people don't or haven't in the history of this class, so hopefully it'll work for you too. And what I've got here are 2 mystery waves. And so this is basically giving you what their samples look like starting at time 0. And then there's 12 total samples. So if you go from 0 to 11, that's 12 total. These are the amplitude values for each of the 2 mystery waves at each particular point in time. So for sample 2, this one is 1.116, this one is 0.533, so on and so forth. Use these. So this is optional. So this will only make sense if you have read through those extra notes that I posted, but did not post a video lecture for. So these extra notes on spectral analysis, which walk you how to do this process. So you can apply a Fourier transform effectively to these particular mystery waves and figure out what their component sine waves, what their harmonics are, both in terms of the harmonics intensity, i.e. amplitude, and their frequency. And so these are supposed to be sampled at basically 12 hertz. So this is supposed to be 1 second long if we look at 12 samples of these creatures. And these mystery waves, both of these on the bottom here, are composed of some combination of these potential component waves, which is what they're labeled over here. So based on the math in those extra notes, based on the structure of these potential component waves and the values for amplitude during the samples of all the different mystery waves, try to figure out which of these potential component waves are being added together to create these mystery waves. Also figure out not only what frequencies those components have, but what their amplitudes are overall. So I'm not going to tell you explicitly how to do that. You have to figure that out on your own, which is why this is extra credit. And I think I've said most of what you need to know here already. The waves have been constructed from some combination of sine and cosine waves between the frequencies of 1 hertz and 6 hertz. All waves involved have been sampled at a rate of 12 hertz. Your task is to perform a spectral analysis on the complex waves. So you should inform you of the spectral makeup of both waves by drawing power spectra for each wave. And you can do this either like on a piece of graphing paper or whatever longhand, or you can make the graph by computer like an Excel or something similar. But what I want you to plot on those is the amplitude of the wave, amplitude of the individual component waves against their frequency. So on the x-axis, you should see frequency. On the y-axis, you should see the amplitude of that wave. Normally when we do or create power spectra in Prot, we see the intensity on the y-axis, but that's going above and beyond the Call of Duty for this exercise because there's no easy way to relate the amplitude of these waves to something like intensity. So please plot the amplitude, and what I mean by amplitude is the peak amplitude of those waves against their frequency. Also, list those values in a table so that it's clear what you think the exact amplitude and frequency values are for each component wave. Also, as above, if you do this, send me the work you did to calculate these values in the table as well. You're not going to get full credit for this exercise if you do not send me that work, because I need to know what you did. This is not super easy to do. It's within your capability, but it will take some work, and I want to know what work you did to get there. So I've given you all the waveforms of the potential component waves. The lecture notes should guide you through the rest. If you have questions, you should ask me. I've got a little pro tip here. If you do this in Excel and you wind up with some sort of value that looks like this, with like a big decimal number here and then a big E with like something like minus whatever after it, this is 0. This is the number 0. Don't act like this is not 0 and has some sort of meaning to it. This is the result of what's called a rounding off error in the computer, and it's not reflective of mathematical reality that you would care about for this problem. So don't forget about this. Work your way through this. If you get it done, you can get up to 5 extra credit points, but again, this is optional. And I'm going to tweak a little bit of this language here to make it match up with what I just told you, but otherwise I think that's what you need to know for this assignment. Send me your answers by email or through the D2L Dropbox, and that's it. Have fun.